Good morning, Townview. Welcome back to Chemistry Online.
All right, y'all, let's go ahead and get started. So today we're going to be talking about stoichiometry. We're going to continue from where we left off. Last thing we did were two-step conversions. So before we get into that, I would like to start by going over two steps so that we can jump into three-step today. So first of all, I wanted to show y'all what a two-step is going to look like. So there's a total of 6 varieties of two-step. So either you start at mass of A and end up at moles of B. So this is going to be one variety right here, or volume of A to moles of B, or particles of A to moles of B. Those are 3 varieties of two-step equations. Now, the other variety is going to be if we start at moles of A, and then we go to mass of B, or moles of A to volume of B, or moles of A to particles of B. Those are the total, those are all the varieties, and we're about to solve through all of them. So let's go ahead and go through that. All right, so looking at this, it says how many grams of chlorine gas are required to react completely with 5 moles of sodium. What I want y'all to notice about everything on this slide is all of our given information is given to us in moles. So our given information is all in moles. And in the first one, they're asking for mass. In the second one, they're asking for volume. And in the third one, they're asking for particles. So it's one of each type. Let's go ahead and solve through them real quick. So again, this is a two-step. So let me set up for a two-step. Okay, so what is our given information for the first one? 5 moles of Na. Now what goes in this box down here? Moles of Na. So because I started with moles, the next step is going to be mole ratio. And in this one, we're comparing sodium to chlorine. So how many moles of sodium?
2.
And then how many moles of chlorine?
1.
1 mole of Cl2. Good. Now what goes in this box down here? Okay, moles of Cl2, how many? 1. So the next part is just a conversion. We're converting from moles to mass. What is the mass of Cl2? So it's just 35.5 times 2, which is going to be 71 grams of Cl2. So let's go ahead and plug that into our calculator. It's just going to be 5 divided by 2, and then we're going to multiply by 71, and you should have got 177.5, and the unit is going to be this right here, grams of Cl2. Let's go ahead and do the next one. So in the next one, they're asking us for liters. So what is our given information for the next one? Of sodium chloride, that's NaCl. What's going to go in this box down here? Moles of NaCl. How many moles of NaCl? 2, because that's what it gives us in the equation. And then we're comparing again to chlorine gas. So how much chlorine gas? 1 mole of Cl2. And then what goes down here? Moles of Cl2, good. How many? And this time they're asking for liters, so volume. So we're going to put liters of Cl2. What number goes before liters? 22.4. Let's go ahead and plug that into our calculator. It's going to be 25 divided by 2. And then we're going to multiply by 22.4. And you should get 280. And what's the unit going to be? Liters of Cl2. All right, let's go ahead and get the last one on this page. So again, this is a two-step, and we know that because it mentions the word mole one time. What is our given information here? 12 moles of Cl2. What goes down here? Moles of Cl2, how many? 1, because that's what's given to us in our balanced equation. And this time they're asking for sodium, so we're going to put moles of Na. How many moles of Na? 2. What goes down here? Moles of Na, how many? 1. So anytime it's a conversion, we put a 1. And this time they're asking for particles. So how many particles are in 1 mole? 6.02 times 10 to the power of 23 particles of Na. So in your calculator, this is just going to be 12 times 2 times Avogadro. So 6.02 second comma 23. You hit enter, you're going to get 1.44 and times 10 to the power of 25. And this is going to be particles of Na. All right, let's move on. So this time it's giving us grams, it's giving us liters, and it's giving us particles. However, in all of these, it's asking us for moles. So again, it mentions moles one time, so all of these are two-step. This is just the other variety of two-step. Let's run through these pretty quick. So what's our given for the first one? 50 grams of O2. What goes down here? Now, anytime I write grams of O2 or grams of anything, I need to calculate the molar mass. What's the molar mass of O2? 32 grams of O2. And then how many moles is that? 1 mole of O2. What goes down here? Moles of O2. Actually, not O2. Well, no, you're right. Moles of O2. And then this time it's asking us for our ratio. So after moles, it's always mole ratio. And our ratio is going to be comparing O2 to CO2. So what goes at the bottom? 5 moles of O2. And then how many moles of CO2? 3 moles of CO2. So in your calculator, this is going to be 50. Divide by 32, hit enter, times 3, hit enter, and then divide by 5. And you should get 0.937 or 0.934. Actually, no, 0.938. And then our unit is just going to be moles of CO2. All right, let's get the next one. How many moles of C3H8 are needed to completely react with 25 liters of oxygen? What's our given here? 25 liters of O2. What goes down here? Liters of O2. How many liters? 22.4. How many moles is that? 1 mole of O2. What unit goes down here? Moles of O2. Now our last step is our mole ratio. So our ratio is going to be 5 moles of O2 at the bottom. And they're asking for propane. So how much propane? 1 mole of C3H8. Then in our calculators, we're going to do 25 divided by 22.4, hit enter, divide by 5, hit enter, and you should get 0.223. And what's our unit going to be? Moles of C3H8. All right, and then our last one, let's go ahead and I need to clear some space. So for our last one, our given information is going to be 8.5 times 10 to the power of 24 particles of O2. So what goes down here? It's going to be particles of O2. And anytime you plug in particles of O2, you're going to put in Avogadro. So 6.02 times 10 to the power of 23. That's going to be 1 mole of O2. And then we're going to put moles of O2 here. And then it's going to be 5 moles of O2. And they're asking for how many moles of water we're going to produce. It's going to be 4 moles of water. So 4 moles of H2O. And then in our calculator, it's going to be 8.5 times 10 to the power of 24 divided by 6.02 times 10 to the power of 23, hit enter, times 4, hit enter, divide by 5, hit enter. You should get 11.3. 11.3, and our unit is going to be moles of H2O. Any questions on anything we just did? So those are all of our two-step examples. Now we're going to go ahead and jump into the next style. So ignore this one. For this problem right here, I only want to go over this real quick. So how many moles of CO2 can be produced with 50 moles of oxygen gas and 25 moles of C3H8? So this question confuses a lot of students just because you're given two givens. However, I want you to think of this question like if you have 3 boxes of cereal and 1 jug of milk, that's our jug of milk, and the boxes of cereal have 10 servings each of cereal, and the jug of milk has 20 servings of cereal. How much are we going to be? How many bowls of cereal can we actually make? Is it going to be 20, 30, or 50? Why 20? All right, because we're going to run out of milk after 20 bowls. So in this question, you're basically solving for 2 equations, and then the lesser of the 2 is going to be your answer, because at that point, you run out of that particular material. So let's go ahead and set this equation up. So for our first one, so over here, by the way, they give us moles and they ask for moles. So this is a one-step equation. So it's going to be 50 moles of O2. Down here, we're going to put moles of O2. And again, it's going to be 5 moles of O2. And they're asking for CO2. So it's going to be 3 moles of CO2. Now in the next one, also a two-step, our given is going to be 25 moles of C3H8. Down here, it's going to be moles of C3H8. And then based on our equation, it's going to be 1 mole of C3H8. And then at the top, it's going to be 3 moles of CO2. Now to calculate this, the first one is going to be 50 divided by 5, that's 10, times 3 is 30. So we have 30 moles of CO2. So with 50 moles of oxygen gas, you can produce 30 moles of CO2. And then with this next equation, it's going to be 25 times 3. So we can produce 75 moles of CO2 with 25 moles of propane. So how much CO2 will we actually be able to produce if those are the two things that we have? So 30 is going to be our answer. We do not add these together. We just look at the lesser of the two. That's going to be our limiting reactant. So in this question, what's our limiting reactant? Propane or oxygen? This one is going to be our limiting. And then what is C3H8 going to be? Excess. This is the one that's not going to run out. So the next question, how many moles of CO2 can be produced with 60 grams of oxygen and 45 grams of C3H8? This is just the two-step version of the same question. I'm not going to go over it. You just solve for 2 steps. Your final answer, the lesser of the two, is going to be the correct answer. Let's go ahead and move on. So we're going to jump straight into 3-step. All right, so how many grams of water are needed to completely react with 85 liters of oxygen gas? I'm going to solve the first one with you, and then the next ones you're going to be solving on your own. So if you want to write this down, you can. If you don't want to, no big deal. So everybody make sure you're looking at my screen. What is our given information for this equation here? 85 liters of oxygen gas. Now, what unit goes in this box down here? Liters of O2. What number goes in front of liters every time? 22.4. How many moles is that? 1 mole of O2. Good. Now, what goes down here? It's going to be moles of O2. It's not going to be 1 mole of O2. It's just going to be moles of O2. So after moles, what step comes after every time? So this is going to be our ratio. And our ratio is going to be O2 at the bottom, so 5 moles of O2. And here they're asking us how much water we can produce, so that's going to be 4 moles of H2O. It says how many grams of water, so our last step is going to be to convert to grams. What goes down here? It's going to be moles of H2O, and because we're just converting units, we're going to put 1 mole of H2O. They're asking for grams of H2O, so our next step is going to be to calculate the molar mass. So molar mass is going to be oxygen times 1 times 16, hydrogen times 2 times 1. We multiply straight across, that's going to be 16 and 2, 18 grams per mole. That's the molar mass of water. So up here, we're going to put 18 grams of H2O. So a 3-step is actually easier than a 2-step because it's going to be the same thing every single time. Everybody look at my screen real quick. I'm going to get rid of these arrows just to clean this up a little bit. So in every single 3-step problem, the first step is always what? Convert to what? Your first step is always convert to moles. It's never anything else. It's always convert to moles. What is your second step? It's always going to be mole ratio. And then what's your last step? It's convert to desired unit. Sometimes it's grams, sometimes it's liters, sometimes it's particles. But this is, 3 steps are really easy. Students like them because it's the same thing every time. First, you convert to moles, then to mole ratio, and then it's convert to your final unit. Let's go ahead and plug this into our calculator. We got 85 divided by 22.4 times 4 divided by 5 times 18. And you should have got 54.64, and that's going to be grams of H2O. All right, are you ready to try on your own? All right, let's go ahead and take a look at your first problem. So do y'all want me to go over the variations? Okay. I'm not going to go over the variations, but basically it's 9. So you could start at... Yeah, it's basically 9. And anyway, don't worry about it. All right, let's move on. So how many grams of CO2 are produced when 50 grams of oxygen gas is consumed? So does this question mention the word mole? So how many steps is this? 3 steps. Anytime the word mole is not in the question, you're looking at a 3-step problem. Go ahead and solve it. I'm going to give you guys 8 laps. Okay, let's go ahead and take a look at this first one. So it says, how many grams of CO2 are produced when 50 grams of oxygen are consumed? So we already know this is a 3-step. What's our given here? 50 grams of O2. What unit goes down here? Grams of O2. Anytime we write grams of something, we need to calculate the molar mass. Molar mass of O2 is what? 32 grams. How many moles is that? 1 mole of O2. Next up, it's going to be our ratio. Which one goes at the bottom? Moles of O2, and our ratio is going to be 5. And here we're comparing it to CO2. So what goes at the bottom? Top? 3 moles of CO2. What unit goes down here? Moles of CO2. Our last step is a conversion, so it's going to be 1 mole of CO2. Then we got to calculate the molar mass. So we have carbon times 1 times 12, oxygen times 2 times 16. So this is 32 plus 12, so 44 grams of CO2. Up here, we're going to put 44 grams of CO2. And now we can plug it into our calculator. It's going to be 50 divided by 32, hit enter, times 3, hit enter, divide by 5, hit enter, times 44, enter. You should get 41.25. Hands up, that's what you got, 41.25. And what's our unit going to be? Grams of CO2. All right, let's go ahead and work the next one out. So for the next one, what is our given? 25 liters of O2. What goes down here? It's going to be liters of O2. Now, anytime we write liters of O2, what's the number that goes with it? 22.4. That's our constant. How many liters is that? Or sorry, how many moles is that? 1 mole of O2. Our next step is going to be our ratio. Which one goes at the bottom? Moles of O2, and it's going to be 5. At the top, it's going to be propane, so 1 mole of C3H8. And then what goes down here? All right, moles of C3H8. And because it's a conversion, it's going to be 1 mole. And then we just got to calculate the molar mass. So we have carbon times 3 times 12, and then hydrogen times 8 times 1. So what's 3 times 12? And then 8 times 1 is 8. That gives us 44 grams. So 44 grams of C3H8. So let's plug that into our calculator. It's going to be 25 divided by 22.4. And then we divide by 5. And then we multiply by 44. And you should get 9.82. So 9.82. And what's our unit going to be? Grams of C3H8. Good. All right, so let's go ahead and I'm going to give you all a few more laps and then we'll solve the next one. The next one is not any different. This time we're starting with mass, ending with particles. Okay, let's go ahead and solve this one real quick. So we have our given information is going to be 85 grams of O2. What unit goes down here? How many? How many moles? 1 mole of O2. What goes to here? 5 moles of O2. And then here they're asking for water. So what goes to the top? 4 moles H2O. What goes down here? Moles of H2O. It's going to be 1. And they're asking for particles. So it's just going to be 6. All right, times 10 to the power of 23. And that's going to be particles of H2O. Particles are molecules. Let's go ahead and plug it into our calculator. It's going to be 85 divided by 32 times 4 divided by 5, and then multiply by 6.02 times 10 to the power of 23. So I got 1.27 times 10 to the power of 24. 1.27, and that's going to round to 1.28 times 10 to the power of 24. And that's going to be molecules of H2O. Hands up if you got this answer. All right, good. Let's go ahead and move on to the next one. Okay, so now that we've done enough practice of 3-step, what we're going to be doing is percent yield. Percent yield just adds one additional step to what we've been doing. So let's go ahead and take a look at it. So top of your page, you're going to write percent yield. And percent yield is basically just telling you how much you produced versus how much you were expecting to produce. So let's think about it like this. If you get a box of cereal, and this box of cereal says that it's got 30 servings, but it's Cinnamon Toast Crunch, and you love Cinnamon Toast Crunch, and you eat it in one of those big bowls, you get like 4 servings out of it. So what would our percent yield be? So percent yield, there's an equation to it. The equation is going to be actual, which is what you get in real life, divided by theoretical. Oh, yeah. And then we just multiply by 100. So this equation is available to you on your reference material. So I'll show you all real quick. On your periodic table, right here, there's a section labeled Other Formulas. It's right at the bottom of that. So it's not a formula you need to remember. You just need to know where it is when you need it. So actual, this is what you got in real life. So when you ate those 4 bowls of cereal, our actual is 4. Our theoretical, this is what we were supposed to get based on what it said in the box. The box says 30 servings. So it's going to be 4 divided by 30, and then we just multiply this by 100. So grab your calculator, 4 divided by 30 times 100. What is our percent yield? 13.33%. 13.33%. That's not a very good yield. When you're working in a lab, you want your yield to be greater than 95%. So that's where you're aiming at in a lab. For example, if you were trying to produce, let's say, I don't know, 30 grams of hydrochloric acid. If you only produce 1 gram of hydrochloric acid, then you did it wrong. You want your yield to be somewhere around 90%. All right, let's go ahead and do some practice. All right, don't worry about any of this. So here's our equation. So percent yield is actual divided by theoretical. So what is actual? This is the important thing. What is actual? This is what you get in a lab. Make sure you write that. Actual is what you get in a lab. Can you calculate actual? No, you can't. Actual has to be given to you. So I have to tell you, I did the lab and I got this much. So actual is never calculated. Now theoretical, this is what you've been doing. So this is what you calculate on paper. So on the cereal box where it says 30 servings, somebody calculated that. So somebody did the calculation, and that's where they got their theoretical yield. The actual yield, you have to get that either in real life or it's just a number that's given to you in the equation. You'll see what I mean in a second. But actual is what you get in the lab. Theoretical is what you calculate on paper. Theoretical is what you get through stoichiometry. I've seen this question pretty often on the ACP where they just want you to know what theoretical yield is. It's what you get when you do a calculation. So the stoichiometry that we've been doing, what does that calculate? Does that give us actual yield? No, it gives us theoretical yield. It gives you best case scenario. So if you do everything right, this is how much you should get in a lab. All right, let's move on. Okay, so here it says when 45.8 grams of potassium carbonate react with excess hydrochloric acid, 46.3 grams of KCl are formed. Calculate the theoretical and percent yield of KCl. All right, so everybody, I want y'all to lock in. So this is it. This is where I need you. Okay, so here it says when 45.8 grams react. What is this? That's our given. Here it says that 46.3 grams are formed. What is this? That's our actual. So your actual will always be given to you in the equation. That's not something you can calculate. What you can calculate is going to be your theoretical. Actual will always be given to you in the equation. All right, so let's go ahead and calculate this. This might have been the first problem that I solved for you guys. All right, so here's what I'm going to do. I'm going to give you all 6 laps. I want you to solve the stoichiometry on your own. And if you want to calculate the theoretical yield, you can. Or sorry, the percent yield, you can. But we'll go over that in a minute. So start by doing the stoichiometry. So what is our given here? What is
45.5.
so 45.8 grams of K2CO3. What goes down here? All right, so anytime we write grams of something, we got to calculate the molar mass. So we have potassium times 2 times the molar mass, which is 39, and then carbon times 1 times 12, and then oxygen times 3 times 16. Multiply straight across. This is 78, 12, and then what's 3 times 16? 48, and then what are these together? 130 what? 138. All right, 138 grams, and then that's going to be 1 mole of K2CO3. Now that we have moles, what's our next step? Mole what? What comes after moles? Mole ratio, good. At the bottom, it's going to be moles of K2CO3, and it's going to be 1, that's correct. And then at the top, it's going to be how much KCl is formed. So KCl is going to be 2 moles of KCl. And then what goes down here? Moles of KCl. Our last step is to figure out the molar mass of KCl. So potassium has a mass of 39. Chlorine has a mass of 35.5. What are these when you add them together? What is it? 74.5 grams of KCl. Hands up if you got all the work. Okay, that's really good. If you got this far, this is good. Let's go ahead and plug into our calculator. It's going to be 45.8 divided by 138, hit enter, times 2, hit enter, times 74.5, hit enter, and you should have got 49.5 after you round it, and that's going to be our theoretical. So we have our actual, it's going to be 46.3, and now we have our theoretical, that's going to be 49.5. So let's go ahead and plug that into our calculator. So 46.3 divide by 49.5, and you should have got 93.5 after you multiply by 100. So times 100, it's going to be 93.5. And that's our percentage. That's our percent yield. Hands up, you got this.
Mr. Ashley got it.
All right. Let's go ahead and we're going to end it right there. Next video I make will probably be only this. And that's it.
If you don't know how to do chemistry, hit that subscribe button. Let's go!